Hello, this is the video in continuation to module 8 and let's trace back the Big Bang Theory and let's go back to 13.8 billion years ago and let's try to imagine what would have happened at that point of time and how we have come to today. So this video is all about that, and also we will try to compare the two theories, the steady state theory and the Big Bang Theory. The Big Bang Theory is also known as evolutionary theory. It was proposed by George Gamow. In Big Bang Theory, it is assumed that before the Big Bang, all matter and energy in the universe was compressed into a speck smaller than one atom, a singular atom. At the time of Big Bang, there was a rapid expansion, an explosive expansion. Please bear in mind, it's not an explosion, but an expansion. The universe has been expanding ever since. Big Bang Theory says that universe has an origin. The time, space, matter, and energy were created during the Big Bang. This is a very mind-boggling concept to digest, that time and space were not there before the Big Bang. So time and space, energy, matter, it was all created during the Big Bang. Let's look at the steady state theory. It was proposed by Fred Hoyle. The universe has always existed and will always exist. This is the basis of steady state theory. It also says universe is expanding. The density of universe does not change as new matter is constantly created in universe. So Hoyle suggested that yes, the universe is expanding, but so is the matter in its expanding. And therefore, the density of the universe is not changing. It also suggests that the universe has no beginning or the end. If we look at a diagram, then it will be easier to just compare the two theories quickly. Evolutionary theory, that the density of matter decreases over time, but overall space is increasing. Steady state theory says that the density of matter is constant, as you can see in both the diagrams. In steady state theory, the dots that represent the matter or the stars or the galaxies in general in space, it is increasing at a rate at which the space is increasing. Fun fact. Hoyle sarcastically used the name Big Bang. It was actually named as evolutionary theory, but it was so cool that it stuck. Because the Big Bang Theory has won, we all know that Big Bang Theory won. So therefore, there must be some evidence that favored the Big Bang Theory. We have already seen in previous video redshift, that redshift proves that the universe is expanding. But that proves for both Big Bang Theory as well as the steady state theory. So there must be some other evidence that favors the Big Bang Theory. Let's watch this video together and it will tell us which evidence we are talking
A channel with no station in your area, not picking up any signal, you will see a... In this video, we're going to look at the Big Bang Theory and the evidence to support it. The Big Bang Theory states that the universe began with a colossal explosion about 13,700 billion years ago and has been expanding ever since. There are two pieces of evidence for the Big Bang: cosmic microwave background radiation and redshift. Disconnect a TV from any cable connection. Tune it to a channel with no station in your area. Not picking up any signal, you will see a fuzzy picture that we commonly call static or snow. The technical term for this static is white noise. Now imagine attaching a TV to an antenna large enough to pick out even the weakest signals from all that noise. To further enhance your ability To pick up weak signals, you would need to eliminate all background sources of noise. So, imagine systematically identifying and then eliminating all possible sources of noise. In the early 1960s, Arno Penzias and Robert Wilson did just that. They weren't using their TV, they used a microwave receiver attached to a large horn-shaped antenna. They were working for Bell Labs, who wanted to use the microwave receivers they had developed for long-distance communication. To pick up the weak celestial signals, Penzias and Wilson worked to eliminate all the noise originating from their antenna and receiver. The last stubborn little bit of noise wouldn't go away no matter what they tried. They even crawled into the antenna, chased away the pigeons, and removed a nest and pigeon poo, but it didn't work. The noise was still there. As the Earth turned, their antenna pointed to different parts of the solar system. If the source of these mysterious microwaves was in the solar system, the strength of this noise should vary as the Earth turned on its axis. It didn't. This suggested that the noise did not originate in the solar system. So where was it coming from? The Earth continued its annual journey around the Sun. If the microwaves originated from a distinct location in our galaxy, or perhaps another galaxy, then the noise level should increase when the Earth was on the same side of the Sun as the source of the microwaves. The noise level didn't change as the Earth orbited the Sun. Penzias and Wilson were confused. Around the same time, Robert Dicke was investigating something called the Big Bang Theory. He thought that if this theory for the origin of the universe was correct, the whole universe should still have some microwaves present. Then Dicke heard about Penzias and Wilson's experiments. The microwaves turned out to be what was left after 10 to 20 billion years of the expansion of space, being the remains of the heat of the Big Bang. These microwaves are called cosmic microwave background radiation, or CMBR. So what about the other evidence for the Big Bang? Redshift. Redshift shows how the light from distant stars is shifted to the red end of the spectrum as the wavelength increases. The further away the star, the greater the red shift, which means the more distant a galaxy is, the faster it is moving away from us. This suggests that the universe is not static as was once thought, but is in fact expanding. For more on the redshift, watch this video.
These two scientists, Arno Penzias and Robert Wilson, they won the Nobel Prize for this discovery. And it is actually called a radio fingerprint of the early universe because the CMB radiation, the cosmic microwave background radiation, are because of the Big Bang. A correction there in the video, it says that 13700 billion years ago, but no, it's 13.7 billion years. Now let's look at the timeline at what happened at the Big Bang. So it started with inflation. This inflation lasted only for 10 to the power minus 34 seconds. But during this inflation, universe expanded to about 10 to the power 50 times of its size. If inflation would have lasted any longer, atoms could not have been formed. In parallel to the inflation, pair production started. With pair production, I mean the particle and antiparticle, or matter and antimatter. So for every plus, a minus was created, to understand in a layman term. All right. So for everything, there was a counter of it. Okay. So particles and antiparticles were created, but whenever particles and antiparticles, they meet, they annihilate. The word annihilate means that they get destroyed or they just vanish, creating a high amount of energy. Okay, so particles and antiparticles annihilated and produced high energy gamma photons. Now, what did these high energy gamma photons do? They further collided and form new particle pairs of particles and antiparticles. As the temperature kept on decreasing, it was too low for the high energy photons to collide and form more particles and antiparticles. And therefore, more and more particle and antiparticles started meeting and annihilating, and therefore the result was great amount of radiation. And this was the origin of the CMB radiation that we have seen in the previous video. As time passes, the CMB radiation has moved to microwave because its wavelength has become so long. All right. As the particle and antiparticle, or matter and antimatter, they kept annihilating, then after all the annihilation, why some matter was left? Big Bang theory suggests that to every 1 billion antimatter, 1 billion and 1 matter was formed. There was an asymmetry in the formation of matter and antimatter, which resulted in today's universe. So after all the annihilation, no antimatter was left. What was left was only matter, and that is what has created our universe. After the pair production comes formation of simple elements. In the first few seconds of the universe, while the temperature was way too high, elements called quarks combined to form protons, neutrons. Temperature was still high, so hydrogen, helium, and lithium nuclei could be formed. But after a few more minutes, the temperature dropped below, and it was no more sufficient to do the fusion. And therefore, after hydrogen, helium, and lithium, no more nuclei were formed. Okay, so the fusion process stopped. After that, there was a big dark age of our universe. There was nothing but just dark, dark, and dark. As temperature kept on decreasing, matter started to clump together and gravitational attraction increased. When these small clumps collapsed, huge amount of energy was released, and boom, there was light. Stars were born. Heat within the stars helped the fusion process to restart, and so helium, hydrogen, and lithium, they started fusing to form almost all the other elements in the universe. So this is the timeline of the Big Bang. I have also found a really nice picture which tells us about the history of an age of universe. So inflation ends, proton formation, nuclear fusion where hydrogen, helium, and lithium were formed. Nuclear fusion ends because temperature dropped down. Cosmic microwave background because there was nothing but just energy because of the annihilation. There was a dark age. After the dark age, matter started to clump together, and because of the gravitational attraction, they collapsed. A huge amount of energy was released. Stars were formed and galaxies were formed. And slowly, modern universe started taking shape. All right. I hope this video was of help. My suggestion would be to make your own timeline and have it stuck on your wall of your room. Bye-bye.